All right, one of the questions that you all had about Kotlin's Flow API is how to deal with exceptions. And just like with any other Kotlin code, an exception can be thrown from within our flows. And even though all of the rules of structured concurrency are still in play when we're using flows, well, flows do have some unique opportunities to deal with exceptions, and that's what we're going to look at right now. To help demonstrate how our flows can deal with exceptions, I've got some code here that includes a flow for grocery shopping. And you can see that inside that flow, we're doing a few things. First, we emit each item from our grocery list and print out what it is we're looking for. Then we take a moment to find it in the store. And then finally, when we collect them, we just print out that we added it to our cart. Now, keep in mind that an exception can be thrown from anywhere within a flow. They can be thrown from the emitter at the top, from the collector at the bottom, or from any of the operators in between. In the code that we've got here, if we emit an item that's not in stock, like an orange, then the findOnShelf function is going to throw an exception. So if I run this as it is, we're going to see this just crash after it gets to the orange. So how can we deal with this? Well, just like with any other code, we can always catch the exception locally. So for example, in this case, we could just wrap a try-catch around the call inside our transform lambda right here. And naturally, this is going to prevent the exception from ever escaping out of this transform operator's lambda. And this way, the exception is not going to crash our app. We can continue with the rest of the flow and everything finishes successfully. So again, if the exception never escapes the operator's lambda, no special handling is required. Now, for those cases where we don't catch the exception locally, so for example, let me revert this code to what we started with, then in this case, the exception will escape out of the bounds of the operator. And when that happens, the exception is going to work its way downward through the flow operators until it hits the collector. And once it gets there, it's going to throw it. So at that point, it's going to be up to the surrounding code to catch that exception, just like normal. So to catch this exception from outside the flow, we can wrap our collector in try-catch. At the moment, our collector is just kind of tacked on right at the end of the rest of the flow, so we could just wrap the entire thing in a try-catch like this. And one difference here between this try-catch and the previous one is that when we catch the exception after the collector throws it, like we're doing here, then we abandon the flow. So you can see here, once we started looking for the orange, we discovered it's out of stock, and then we're done with the grocery shopping. So last time, if an item wasn't in stock, we just substituted that one item. But with this code, if an item isn't in stock, we stop grocery shopping altogether. Now, if you want to catch the exception from outside of the flow, like we're doing here, just keep in mind that the collector is the part of the flow that actually throws that exception to the outside world. So that's the part that needs the try-catch around it. Remember, we can separate the building of a flow from the collecting of a flow, in which case it would look like this. Since the collector is the part that actually throws the exception, we would want to put the try-catch around just that part. And if we run this, it's going to produce the same result as we had last time. Now remember, this part of the code right here is just building the flow. It doesn't execute it at all. And in fact, we could even collect this same flow multiple times. Because this part is just building the flow, there's really no reason to wrap it in a try-catch. Doing that would only catch an exception that was thrown during the building of the flow, not during its execution. So instead, put that try-catch around the collector because it's the one that actually throws the exception from the flow to the outside world. Also keep in mind that the exception that the collector throws could be a cancellation exception, and you don't want to accidentally swallow those here or your coroutine won't be properly canceled. So you'll either want to catch a specific exception, like I'm doing here, or if you do need a more general catch-all for some reason, just make sure that you rethrow any cancellation exceptions. Now, as we saw, wrapping our collector in a try-catch prevents the rest of the flow from running when there's an exception. But sometimes we might want one last chance to emit some values in response to an exception. So for example, when a grocery item is out of stock, maybe the grocery store wants to provide the customer with a coupon to apologize for the inconvenience. And this is where the catch operator can be helpful. So here's the same code again, but I removed the try catch and I switched from the transform operator to the map operator. And now we can add a catch operator here like this, and we can use this to emit an apology coupon at the last moment. Now remember, the exceptions are going to flow downward from the point where they're thrown. And this means that the catch operator is only going to be able to receive exceptions that were thrown upstream from where it's located. So make sure that you place your catch operators at a position in the chain below the point where the exception is thrown. I'm going to give this a run just to make sure that in the output we see the coupon. And there it is. Great. Now, by the way, if you catch an exception with the catch operator, you're also preventing propagation of that exception, just like if this were a regular try-catch block. So if we were to add another catch operator below this one, then when we run this, we won't actually see the apology message here printed out. So we did get the coupon, but we didn't get the apology message. So if we want to allow that exception to continue working its way down after you've caught it in the first catch operator, then you certainly could rethrow it just like this. And I'm just going to run this to demonstrate that this does indeed work. And here you can see we get both the adding to cart $5 coupon and the apologies. So we can see that both catch operators now run their code. But catching and rethrowing like this is a little bit awkward, so I would tend to prefer a single catch operator that just does everything that we want, like this. And I'm going to run this and we'll see that it produces the same output as we had last time, but we didn't have to do that kind of awkward rethrowing. So there you go. You can use a try catch inside the flow, or you can put it around the collector, or you can use the catch operator. And by the way, for those cases where you want to rerun the flow whenever an exception is thrown, there are some retry functions that you can take a look at too. But for now, we're going to wrap up this video. In fact, I intended for this video to be the final in the series, but last time one of you asked about state flow and shared flow and about flows versus channels. And I replied saying that if we got enough likes on that comment that I would cover those topics as well. And sure enough, you all exceeded the goal by like over 100%. So we're going to take a look at those soon. Now, keep in mind that Kotlin Conf is just a couple weeks out too. Thank you so much to everybody who nominated me and voted for me in the Golden Cody Community Awards. You all are the ones who are making it possible for me to attend the conference this year. So thank you very much. And hey, if you're going to be at Kotlin Conf, be sure to flag me down and say hello. I would love to get the chance to talk with you. Well, that's going to do it for this video. Remember to like, share, subscribe, and eat your vegetables.